So a little bit about us here at Seaward Group USA. We're based in Tampa, Florida. We're a sales and technical support office for Seaward electronic devices, which are manufactured in the northeast of England in the United Kingdom. We're not only involved in the solar industry, we have a wide reach. We manufacture test instrumentation for solar photovoltaics, for the wind energy industry, biomedical engineering, production line safety testing, electrical safety, and high voltage. Be sure to check out our YouTube site, Seaward Solar. Just have a look for that on youtube.com, search for Seaward Solar, and you'll find our Seaward Solar YouTube page. On there we have a variety of webinars and FAQs, and that's where we'll be uploading this video after the webinar is completed today. You can also then leave comments and subscribe for future videos if you miss any webinars, or if you need any FAQs or want to look at some specific points during the webinar. So a little bit more about us on the solar side of things. We're a member of the Solar Trade Association in the United Kingdom. They're a group who lobby for the solar workers and solar professionals across the United Kingdom. We're also a member of the California Solage and Storage Association. They lobby, again, the California governing bodies to keep the largest solar market in the US and certainly one of the largest in the world going. They're a very good association. Similarly, across the USA, we're a member of SEIA, the Solar Energy Industries Association. We're also a member of NABCEP, and we offer NABCEP-approved courses for continuing hours for solar PV installers. And also we regularly donate our PV test equipment to Solar Energy International, who are a great not-for-profit group that have operations around the world and are based in Colorado, USA. So on the left here, we have traditional tools, and on the right, we have solar PV tools. And this is basically what our webinar is going to cover today: why we need to move away from traditional electrical tools and more into solar specific tools. Well, on the left, we have a traditional amp clamp. Okay, so pretty standard. We'll give you current, but the clamp on the right is specifically for solar PV, so we can make tests in line. You can see the MC4 connections there. It also has a wattage reading, and it's specifically designed to test a solar PV array. Also, the multimeter here down on the bottom left, an old traditional multimeter, one that we manufactured here at Seaward. It doesn't have the capabilities to measure temperature, which is going to affect our voltage. It doesn't have a high enough range or accuracy for solar PV. And similarly, if we use a separate insulation tester, we're not getting context for our results. And we're also having to use 2 or 3 pieces of equipment and write down those results. Now, if we use traditional solar PV tools, we can record all of the results in an automatic test sequence. We can make a report, we can take a radiance, we can take voltage, and I'm going to explore these concepts a little bit more in the following presentation. I'll give you some case studies, some examples, and some more reasons why we should switch across from traditional electrical tools to solar PV specific tools. So the main concept we have here for understanding what is going on with a PV system, both in terms of electrical safety and performance verification, we take a voltage reading and we take a current reading, or short circuit current reading. And if we don't have context for those results, for instance, we're using a traditional multimeter and we're not taking cell temperature, or we take a traditional clamp and we're not using, excuse me, that is incorrect. Had to make a correction to the presentation. Apologies. So open circuit voltage is affected by temperature, and short circuit current is not affected by temperature, it's affected by irradiance. So it's very important that we take those two values as we take the voltage and the current readings. So what we can do with that is very simple. So we would take the open circuit voltage of a single panel at standard test conditions. So say, for instance, that's 40 volts. We multiply by the number of modules in the string, that's 400 volts. So if we add a multimeter, that's as far as we can get. But because we take a temperature coefficient, because we take a temperature reading rather, we can add a temperature coefficient to those details. And we can figure out, okay, well, it's not supposed to be 400, it's supposed to be 380 because the temperature is really high. And then by taking our expected value and comparing it to the measured value, we can figure out what's wrong. And I'm going to explain this concept in more detail. Similarly with current, we can take the ISC of the back of the panel, and that will be at 1000 watts per meter squared, and we can also add in a performance factor. Now, if we're just using a clamp meter, we get operational current, we have no idea how the irradiance is affecting its output. So therefore, we can't get an accurate expected value. So our measured value has no context, and it's almost rendered meaningless. So really, by using traditional tools, we're not getting all of the information we require. We need those environmental conditions tested and verified at the point of test of voltage and of current. So we can do that with a more robust solar PV tool like our PV210. So you can see here that this is going to give you open circuit voltage, short circuit current, insulation resistance, the IV curve. There's also an amp clamp. We're also going to take irradiance, cell temperature, and ambient temperature, and we're going to run through those tests in about 30 seconds. So rather than having to get out your insulation tester, then the voltmeter, then the clamp meter, and doing separate tests and recording them all individually, what this will do is put it all together in one single reporting form for you within about 30 seconds. So we're going to show you some examples of that in the field now. So here is a site in Northern California near Fresno, and you can see this panel is very, very soiled, which is typical for the area. It's almost a desert area. So what we did was we used our expected values of based on the current irradiance and cell temperature to figure out what our voltage should be. So we looked at the STC conditions of the panel and then figured out what the expected should be. And based on the irradiance that we were reading and the temperature that we were reading, we said, okay, when we run a test on this panel, what I should see is 37.4 volts open circuit and 8.1 amps short circuit current. When we took the measurement, we actually saw that the measured VOC was 33 volts. We'd lost 11.6% of the voltage. And the measured ISC, we saw a drop of over 30% to 5.64 amps. So we can tell now with the context of our expected results that our measured results were being affected. So you can see quite clearly in the picture it's because the panel was soiled. So we would not know that, not doing a visual inspection of the panels, and we wouldn't be able to represent that to the customer if we didn't also take our irradiance and our cell temperature values. You could then go one further and take an IV curve trace at the same time and further represent this to your client. So one of the key tools that we're using there, which is not usually used with traditional tools, is an irradiance meter. Our irradiance meter will also take the plane and inclination of the panel, so you can check that during the maintenance. There's also a logging function. So I would say whenever you're using and testing PV systems, be sure to take irradiance and be sure to take cell temperature. We can also make better points of connection with a traditional PV tool. So you can see here on the left-hand side, our PV210, we're actually using our combiner box test leads. So here we've connected MC4s to an alligator clip, which can then be used in the bottom of the inverter, which you can see here on the left in a domestic property, and here on the right in a utility scale plant in a Sunny Boy. So we can make multiple points of connection that maybe a traditional tool cannot. Carrying on that theme, we can make a connection up at the J box. And again, when I say make a connection, that enables us to take open circuit voltage, short circuit current, insulation resistance, an IV curve trace, the irradiance, and the cell temperature with ambient temperature, all with one push of a button taking about 30 seconds. So we can do that at the inverter as shown or at the J-box. Also, we can do it at a panel level. So we can make multiple connections to the array at multiple points. Again, carports are not a problem. As you can see here on the left-hand side, we just need to get up there. And again, we would connect the irradiance meter to the top of this carport. And that is super important on some of these carports with varying, that are quite large, that have a steep incline, because the top panels will be having a different irradiance to the bottom panels. Therefore, you need to get accurate irradiance figures, which you wouldn't be able to get with traditional tools. Similarly, here on the right-hand side, we decided to take some panels off the rooftop and do some testing down by the van side. So the flexibility and the headroom of this tool, we have 1000 volts maximum at 15 amps short circuit current maximum, which means we can string together a single panel, 16 panels, and we can find out different things about the different configurations of panels, again, all while taking irradiance and accurate cell temperature readings. So that's all well and good. It's going to improve the testing process. You don't have to use multiple tools, an insulation tester, a clamp-on. You're getting increased accuracy. You're able to calculate your expected values and compare them to your measured values with an educational approach. And then also at the end of the day, we can come back into the office and use a tool such as SolarCert here, which is going to generate a good string report for you. You'll be able to see performance ratios, fill factors, all of the information you took on site. We can then feed that into the software, tell it which panels and module we're going to be using, and then it will give you a nice generation report. So that is true for our PV210 and PV150. So those instruments, they're looking to replace your traditional mega or insulation tester. It's going to replace your multimeter. It's going to replace an amp clamp. It's going to replace an IV curve tracer, and it's also going to add in irradiance, cell temperature, the inclinometer, the azimuth. So you're getting a lot of tools which are specific to solar PV testing, and we're getting rid of the older traditional tools which are really slowing you down. And then, of course, we can output to our SolarCert software. But if you're dealing with larger scale plants, there are other challenges which we have to overcome, which traditional tools can't. So first and foremost is the scale of utility scale solar PV plants these days. When we look at the architecture of the panels, we're looking at 1500 volt strings. Often those strings are paralleled into a single fuse, maybe a 30 amp fuse. So what we're dealing with, what's in front of us, is very different to a carport or a rooftop array. So we need something that's specific for that architecture. There's no point taking a 1 kV voltmeter there. That's not going to do it. And also we can't be shorting out those panels quite easily. So what we devised was a Solar Utility Pro kit. So this is going to hit the headroom of the 1500 volt 40 amp that you need to work on a utility scale PV plant. We also looked at the design. So often tools are not designed for such rugged environments. Well, ours is housed in a Pelican case. And again, you're going to get the irradiance and the temperature detail. So here you can see the instrument being used in the field. The picture on the left was actually a prototype version. You can see we're giving additional cables, and we always advise when working in a combiner box that you are in line with any arc flash or health and safety requirements. Be very sure to have covered those points prior to the point of connection. Here on the right hand side, you can see again the instrument is comfortable working inside this combiner box environment. So I have a question here from Laurent. Is this device better suited to plus 22 solar module strings than using the PV200? I would say that's a very good question. Laurent's question is based on the length of the string. It really depends on what voltage the panels are. So 23 panels at say 50 volts, that would be quite high. But generally, anything over 1,000, we don't want to be using the PV200 for that. That would definitely be the Solar Utility Pro. But we can help you calculate those values. And it's also key to note that it's not just the voltage rating, but it's also the current rating we need to be aware of. So the PV200 is rated at 15 amps. The Solar Utility Pro is rated at 40 amps. So that gives us a lot of headroom for any overcurrent situations. Thank you for the question. All right. So we can obviously then, using this high headroom we have of 1500 volts, 40 amps, we also have solar specific connections, just like the other device. We're also saving the results. We're saving voltage, current, irradiance, and cell temperature in one rugged device. And we can test a combiner box very easily here. So we would open up all of the fuses. If they are negatively fused, just open up all of the fuses, connect to the common negative, common positive, and then we simply infuse, we simply insert one fuse at a time, test, save, open the fuse, next fuse, test, save. And then this way we can test at these 30 amp fuses, multiple strings in parallel, very quickly using the Solar Utility Pro. And again, it'll all be saved into the software. So the instrument can again be used at a string level, but you can see it works well in rugged conditions and it travels really well in its Pelican case. So we're nearly coming to the end of our presentation. I just wanted to further cover some of our original points. So you can see that when we're using more traditional PV tools, we're not getting enough information. So if we're using a traditional clamp, a traditional voltmeter, a traditional insulation tester, we're not going to get the irradiance and cell temperature at the same time. We're not going to be generating a report. We're not going to be able to see an IV curve, and we're not going to have the proper connection tools. So by using more solar specific tools, you'll be able to get a much better report for your client. You'll be able to troubleshoot problems quicker. You'll be able to commission plants quicker, and you'll have a much better picture of what's going on with your PV system. So thank you everyone for joining me today. I'd like to open up the floor now to any questions that you may have. I'll just quickly touch back on Laurent's question. He was asking which device is better suited for which type of plant. Well, the PV200, PV210, PV150, I would recommend those for residential, commercial, and utility scale systems under 1000 volts. And it also depends on, what the fuse structure is in the combiner box. And then the Solar Utility Pro, I would recommend definitely for any utility scale plant. It can hold 1000 records. It'll replace your voltmeter, do the current test at the same time. It's really been a great start for us. So another great question, could Seaward promote a forum among users of your equipment to exchange ideas and ask questions between installers? Certainly, yeah. I mean, we are trying to encourage the Seaward Solar YouTube site a lot. So please feel free to visit that. There is a good comment section there. Other people that view the video can then feedback. So there is also a lot of smaller videos on there. I'm also happy to receive feedback via email. We also have a LinkedIn page, but we haven't set up a forum as such for people to discuss. But that's a really good idea. That's definitely something we could look into. Okay, well, I'd like to thank everyone for Corey. Corey asks, any tips on finding arc faults with the PV210 and how do we label the strings on the computer? That's a really good question. Corey, it's probably another webinar is safely commissioning and maintaining 1000 volt arrays. But what we'll do is I know we need to get you guys some training. So let's follow up with a separate session, and I'll give you a full training when we can get the instrument out here, and I'll show you how to make the connections and how to use the software. So that's available to everyone. I can give you a demo or training on any PV equipment specifically. And Corey, I'll get in touch with you right after this meeting. Okay, I don't see any other questions coming through, so I'd like to say thank you. My name's Michael. You can send any follow-up questions to michaelm@seaward.com. Also connect with me on LinkedIn, and be sure to check out the YouTube site when you can. Thanks very much.